You got that. Yeah.
I just love that. Like I said, that's
Alrighty, welcome everybody. Thank you so much for joining us today for this Lunch and Learn. We are really glad on behalf of the Center for Applied Artificial Intelligence. My name is Marley Truesdale. I lead the Science and Communication Center. We're really thrilled to have the AI Student Interest Group as well as living with us. So a little bit about the Center for Applied AI. May not have seen us in this building. We're actually located in Gifford, which is right next door, above Plein Cafe. And we support faculty and other research efforts that are happening at Loop in applied AI. So we touch areas like operations, public policy, everything that our faculty are working on related to or that uses machine learning and applied AI. We have supported in the past. We're also increasingly working with faculty and students in the MBA program, specifically those taking courses in AI, as well as help launch the applied AI configuration. So we're particularly interested in hearing from you about what engages you, ways that we can support you with programming. So without further ado.
Thank you. So welcome, Professor. Most of course here are your students, but for those who haven't had the privilege of studying for classes, why don't we start this presentation with a brief introduction?
Sure. Yeah, so it's a pleasure to be here. Some of you are in fact new faces, so that is exciting. So I am not someone who for like 20 years has been interested in AI. I was originally most interested in internal combustion engines, and my father, he's an electrical engineer and science PhD. And my one act of rebellion was to study mechanical engineering. And so I started my career designing diesel engines, and a lot of that involves solving equations that govern fluid dynamics. And most of those solutions we arrive at through basically optimization. At some point in time, in like the early 2010s, I realized that internal combustion engines were dead, and I needed to find a new career. And so I said, well, I can do optimization. I learned about machine learning, realized that it was all optimization. I said, that looks pretty cool. Let me go play with it. And so like many of you, I needed to pivot. And so I went to do an MBA. I was intending to do a master's in computer science as well, but didn't end up finishing that because it wasn't going to affect my compensation. And I had just received a shiny new MBA that told me I should, compute NPV of things. And so did the MBA, pivoted, and went to work at Amazon on Alexa. And so at the time, it was kind of before all these transformer models came out, before these large language models came out. And while I was there, I saw those coming out and thought they were all kind of pretty amazing. And from my MBA, I had kind of learned about the challenges of processing financial text and all the stuff that firms produce. And that sort of piqued my interest in applying these language models to financial problems. And that led me to do a PhD at Wharton, and then eventually come here. So I am in many ways just a slightly older, more broken version of all of you. So, if this is something that is of interest to you, reach out to your professors. We're always interested in doing research and mentoring people. This is a path that we can be on.
Nice. So it's 2017, the white paper comes out and you say,
yep. Not quite as clear as that, but yeah, sure. Let's go with that.
So what we're going to talk about today, involves a lot kind of philosophical issue, which is like knowledge, how we find knowledge and how we measure knowledge. And we're not going to answer them, but we're going to initiate in knowing something and memorizing something. So at high level, how do we know that a model actually knows something or just memorize it and then fitting something?
Yeah, so effectively what Santiago is describing is a classic problem, even pre-LLMs, even in machine learning, something known as test set leakage. Usually the way we would evaluate this, right, is we would train a model and then we would show it examples of the problem we're interested in that you think it has never seen before. And we would observe whether or not there's a big change in performance. So, if we think about this in like a financial markets trading decision context, maybe we have a model that is at some past returns. I know I'm a Chicago professor, so I didn't say that that's informative of the future, but let's just say for whatever reason, we're going to look at past returns and we're going to try to predict whether future returns will be up or down. We would train a model up to some point in time and then apply it on data that came out after that point in time, thinking that that is truly out of sample. However, maybe we make a mistake and we train the model on adjusted prices, which means that the price time series has been adjusted for stock split. And so prices in equities markets, usually the things we're interested in, they're in penny increments, maybe sub penny if we're getting some price improvement, but for the most part, just penny increments. And so maybe this model that we train, it learns that, hey, if the price of a stock is, delineated out to like 10 decimal places, it must have had a lot of stock splits in the future because it was rising. So whenever I see something with a lot of decimal places, I'm just going to go along. We're just going to go on. And so even though we're very careful about saying, hey, we're going to stop the training data in, let's say, 2010, if we're using adjusted prices, which are based on stuff from the future, that is leakage that can feed back into the training process in a relatively insidious way and lead to what looks like outperformance, actually not. So generally, when we think about assessing whether a model has knowledge, we try to do this process where we assess it out of sample somehow.
Right. Besides this example, we can also, generalize into sentiment analysis. At some point, I remember one of your classes you mentioned, we're doing a backtest strategy, for example, and we're running it through 2019. Let's say, go full on zoom and short everything else. Obviously, this is COVID information that it shouldn't have those issues, not just for specific numbers, but also how it interprets news information, pairing calls, and everything that would connect with returns that really know.
Yep. Yeah, exactly. And so this is, more broadly for LLMs where we try to train the model on basically all data that exists up to a specific time. The model is going to have that in its parameters. And just in class earlier today, someone was saying, oh, can't we tell the model not to use stuff after 2019? A bunch of CF, you can do that. And some people do in the finance literature try to do that, but there's a bunch of computer scientists that have shown that these models don't have a good sense of time. And so it doesn't really know what it means to not use stuff from after 2019, unfortunately. And so, you asked about how we evaluate this. It's a very hard problem, particularly for finance. If we want to assess like knowledge versus memorization in math, maybe it's a little bit easier. So if you think about mathematics, there's usually a deterministic answer. Like I give you some numbers, there's some algorithm you can apply and get the right answer. So what we would be trying to test for is, has the model learned that general algorithm for solving the problem? And so there's a lot of different ways we can do that, right? I can give you different numbers, right? So maybe I want to test whether you have learned multiplication or just memorized the multiplication table from 1 to 12. Like any of us had to do at least things. I would give you numbers outside the multiplication table, right? And see whether or not you can get the right answer. If you don't get the right answer, that's evidence that you don't actually know how to do multiplication, you just have memorized the table. I think it's important to denote that like both skills are useful, right? Like to do long multiplication can be kind of slow versus if you just memorize the answer, you can give someone the answer very quickly. And so it's not that one thing is bad generally, but in the finance setting anyways, we are generally concerned with this memorization and lookahead bias.
So at the core, this is another example of why overfitting is an issue. One of the reasons why we get data whenever we're training, do a training section, then we test it out of sample. So we can know kind of for sure that we have a generalized model and not something that's
correct, especially so like traditional machine learning applications that you may have played with in other classes. Usually you'd be very careful to have a training set, a validation set, and a final test set. If you have enough what's known as regularization in your training process, then it's less important. And in fact, there's, a bunch of work that shows that if you have sufficient regularization, you don't even really have to worry about this problem, and you can just like quote unquote overfit, but you're not actually overfitting the data, and it works quite well at a sample. And yeah, so that's, one way of preventing this is just a lot of regularization. And then the typical training process, like for training these LLMs, we use some sort of stochastic gradient descent method that has a bunch of regularization in it inherently. With other things we do too, to help prevent the overfitting problem.
So you have written a bunch of papers in order to measure how much overflow.
Mhm.
Tell us a little bit about that, how use traditional ML prediction model.
Yeah. So language models, they're large language models. So I would say just like first off, when you think about them, think about using them for language tasks. They're wonderful for that. So like sentiment and stuff. But there were some people who were curious and, just experimenting on, can we use one of these models to analyze financial statements or do some sort of kind of analysis that we might expect an analyst to do in terms of producing a DCF or something like that. So one of the earliest papers that showed that look-ahead bias was a problem was basically the example you gave. That said, asked the model some stuff about stocks that were most affected by COVID, and then does the model seem to adhere to a directive of don't need information at the point? And it didn't. So it was like, okay, look-ahead bias appears to be a problem. And so I wanted to try to study that more systematically. And so the way that I did it is that I said, well, people are passing in these financial statements with kind of nothing else. So it was just, here's a balance sheet, here's a income statement. And those numbers in those financial statements basically serve as unique identifiers. So if the model has been trained on that stuff, right? Like think about a press release that announces whether earnings went up or down relative to last year, and it mentions revenue, it mentions, it's the firm's income, things like that. Then even though to human beings, we would have a hard time mapping those numbers to a unique firm, for an LLM, no problem. It doesn't really care. It doesn't rely on things like Lego or Apple to identify a company. It's just looking at sequences of vectors. And so as far as it's concerned, unique numbers are as good as a human readable company name. And so what I showed was that like basically just revenue and net income alone are enough to uniquely identify well over 99% of firms or observations. And sure enough, LLMs seem to be able to do that. And so, yeah, if you just ask, you say, hey, here's, the net income and revenue for a particular year, what firm is this? If it's a big like company like Apple or something like that, it's probably going to be able to get that right for 90+% of the observations that you're asking.
So a follow up of that, some researchers have tried just masking the name of the company. So from what you're saying, that's not really a useful technique, given that it only needs the numbers to know and associate it with Apple, a different stock. It doesn't really need the name behind the numbers to know what is it that we're referring to.
Correct. So there's kind of two elements to this. The first is that even though we do lots of stuff in human language space, the model itself, it is just doing things using vectors. So we have something called a tokenizer, which we pass human language through. That encodes the human language stuff into tokens, which are basically just integer IDs that point to vectors in the model's vocabulary. We look up those vectors, we concatenate them and pass them through the language model. And so as far as the language model is concerned, it doesn't really care that something is human readable or not. And when we train the model, there's kind of two types of models. One is an encoder only type of model, which doesn't really generate text. And that model, we literally train it by hiding some of the input tokens and then telling the model, hey, predict what those hidden tokens actually are. So it's a self-supervised learning task in the sense that we can define the task using the data itself, just predict what has been kind of corrupted or hidden. So when we mask tokens, like the model has literally been trained to break that task. And how does it do that? It uses the unmasked tokens, the context, to infer what those hidden things are. Usually we just mask randomly when we train the model, which is slightly different because the prior research you're referring to, they strategically mask like company identifiers and things like that. But those encoder-only models are literally trained to break that task. So I'm a data-driven guy, so I would say it's an empirical question as to whether or not that's a problem. The empirical data suggests that the models are able to break it. Like if you do this masking for SEC filings, particularly for big firms, like well over 80% of the time, you can guess the firm that produced the disclosure. So it doesn't really seem to work well. Even if you ask a model to first paraphrase the disclosure, and then you remove all the like human readable identifiable stuff, you still get very high accuracy rates like that. And so it doesn't seem to work. For generative models, we have a thing called fill in the middle, which also basically imbues it with this ability to break the masking. And so, it's a maybe clever idea, but ultimately, given that the models are fundamentally different than humans, it's not really the best idea or the best approach.
So as a side note for people to know like which model we're talking about, just an encoder, we can imagine early BERT, it's just do that. You mask different tokens, yet the attention mechanism has access to all future tokens. Some of them, well, not all, but with
everything in the context window, both directions.
Yet generative models, which are decoder only mostly, they also do this masking task, but the attention mechanism doesn't have access to all future tokens because that's what it's trying to predict, right? And that's ChatGPT and some other, all of the other models.
Yeah, so if we maintain our like Western oriented view, we take all text to the left of the current token, we try to predict token that will come next. And we do that for all tokens in the input. So you can kind of imagine a mask that looks like a diagonal matrix, where the text to the right is always hidden.
Right. So we have consensus that this is a problem. Maybe at first researchers weren't that worried about lookahead bias, but now we've seen and we measure how much of a problem it is. So what do we do?
Yeah, I mean, the simplest answer is evaluate at a sample, right? So a new model comes out yesterday, start evaluating right now to see how well the model works. There's something called a knowledge cutoff, which is basically pre-train the model. The data team that assembles all the data that we're going to train the model on, at some point in time, they have to stop working and freeze the data set. And so that knowledge cutoff is basically the newest piece of content in that frozen training data set. So if you think about freezing a data set before a US election, the model would not actually have some information about the outcome of that election. And so you could potentially just say, all right, I'm going to use that knowledge cutoff date, evaluate after that, and treat it as out of sample. It's a reasonable assumption. For those of you who've taken my class, you know that pre-training is just the first phase. We have post-training, which involves humans in the loop, assessing feedback. And so if that post-training phase extends until after an election, and then we sample, a prompt from the model, hey, who won the election? And half of the things are from say Donald Trump, the other half say Biden. Those human beings are likely to say Donald Trump is a better answer than Biden, or well, I guess Kamala. And so as a result, you can have some leakage from the future that flows into the model via this post-training process. But the evidence that I've seen on this and I've played around with a little bit myself suggests that there's minimal leakage. So just as a first step, you could say, all right, I'm going to evaluate the models after the knowledge cutoff and see how well the strategy works.
I thought that post-training was only about format rather than adding more information to the model. So it's not like that.
No. So, I mean, your pre-trained model is probably great at autocomplete. So, like finishing the sentences that you're typing text message chains. But it wouldn't necessarily be very good at following directions. So if you say, hey, go do this task for me, it's not going to be great at that. And so the post-training process is really what took us from just an autocomplete model to ChatGPT. It got the model to follow directions and things like that. And so this leakage that can occur is very much so like an unintended side effect. Like the goal of that post-training process is not necessarily to improve the model with new knowledge, it's to get the model to be aligned with what we care about as humans in terms of preferences. But as a side effect, there is, like academically, there is the possibility of.
So well, in finance, if you wanna test an investment strategy, you wanna go all the way back, right? And if we have these cuts of information during time, there's obviously super associated with newer and newer models, which are better and better. So if we wanna use the latest ChatGPT or GPT structure to predict stuff, by definition, we're gonna be using the whole data set. So this idea of using this cuts of knowledge, although useful, you might be restricted to using models that are in the past that that don't have information about the period that you're concerned about or where you want to do the out of sample testing.
Correct. So this is basically the trade-off that you face. So if you do want to do a long time series of predictions and assess that, then this is the challenge. There are some firms that don't care so much about that, but many firms, whose holding periods are measured in terms of months or years, so they care more about these long time series, and so it becomes a much harder problem for them. And when that's the case, then you sort of have to switch to something else, either being comfortable relying on an older, non-true frontier model, or try to do something else to be able to test the frontier model, or at least get some sense of how much of a problem lookahead bias is. So like in my paper that you were referring to earlier, let's say we give the financial statements to a language model, that's a frontier model, and we ask it to make predictions about earnings. Is it going to go up? Is it going to go down? We see that, hey, it has some accuracy. It seems to be doing better actually than analysts. Is that because it is actually analyzing financial statements, or is that actually just memorize the answer? The one way we can do that is say, well, if it does in fact have a rigorous like mathematical analysis it's doing of the financial statements, if that is the case, then if we introduce a tiny amount of noise into the data, then it shouldn't affect it. And so this is actually something that's very common in the techniques to assess mathematical reasoning. So for instance, let's say I give you a word problem and it says, Santiago and Bradford are having this conversation. How long does it take for Caesar to fall asleep while he's listening? If I change the proper nouns in that math problem, it shouldn't affect the answer, right? Assuming there is a mathematical way to get to the correct answer, changing proper nouns shouldn't have any impact. And so this famous paper from Apple, researchers, they basically showed that if you swap out the proper nouns, you get this huge decrease in accuracy on these mathematical problems, suggesting that the performance that OpenAI was demonstrating was not true mathematical reasoning, but just the fact that the model had seen a question like that before, and it could kind of give the right answer because it had seen. And so you can do the same sort of thing for this financial statement analysis task. In this paper, what I did was I just randomized the least significant digit. So if we have, a financial statement item that is like 1.357 billion, if we change that 7, that's the least significant digit, that should have the smallest impact on the predictions, right? Like presumably the most significant digits are the most important. And what I see is that as soon as you change even just the least significant digits, so just randomly change it to something else, there's a huge drop in accuracy. So basically all the predictive ability disappears, which is consistent with this notion that the model is just relying on its memory instead. So that would be one thing you could do. Like, let's say you think you found a profitable trading strategy, think of ways to perturb the data to be able to assess whether or not it's actually performance from analyzing the content, or is it something else? On one other thing on that, Modern models, so when I did that paper, it was almost 2 years ago. Modern models have reasoning features, which this is where they generate a bunch of intermediate tokens before they give you the final answer. So if we ask a model today to do this financial statement analysis task, predict earnings, we can actually see the intermediate tokens it generates and see like a human readable output of the reasoning that it's doing. And so it's pretty cool. You can look at that and see, and at least what I've seen is that it's basically just doing linear trends. It's like, okay, sales has been increasing, COGS has been decreasing. Therefore, I think that earnings is going to go up next year, which is obviously a very simple analysis. Other things that I've seen, you can actually see it relying on stuff from the future. So it will say, well, oh, I know that next year the earnings went up from this press release that I read. Oh, but the prompt tells me I'm not supposed to use that information, so I shouldn't rely on that. Let me think harder about what's going to happen using these numbers, right? And so, I mean, it looks like the model is thinking and everything. And maybe that is what human beings are doing too. But you can see that the information is there, and it's, kind of dangerous to expect it to not rely on that.
How trustworthy do you think it is to, try to solve this with some prompt engineering, saying, hey, you're fully prohibited to use information after this date?
Yeah. So, I mean, reasoning models, I think that's probably more effective because it can actually surface the information from its memory, including anything that's temporal related, and then it can reflect on the prompt and what it has surfaced and say, oh, maybe I'm not supposed to use that. But there's an awful lot of research that shows that these models don't have a great sense of time to begin with. And so, and I mean, it makes sense. We don't really we don't explicitly try to train them to have a sense of time.
Yep.
There is some research from Google where they do that. They try to I think the paper is called LLMs as time-aware knowledge bases or something like that, where they explicitly try to introduce time in the training process. And that helps, but it's still, it's not perfect. And so my view, I'm very bearish on this. I think that maybe you can prompt engineer your way into something good. But increasingly, I mean, how many people here have done prompt engineering? Okay, so some of you. So prompt engineering, it's not very fun. It's where you sit there and you make tweaks to the prompt to try to get better output. The more robust way to do that is to define some sort of key performance indicator you care about, like maybe the Sharpe ratio of a portfolio that gets constructed, and then run an optimizer to alter the prompt in a data-driven way to maximize that Sharpe ratio. And so that puts pressure on the model to, do well with the Sharpe rating. As soon as you layer that optimizer on, it's like any look-ahead bias that exists in the model is likely to be magnified.
Yeah.
And you can do other things, like maybe you look at the reasoning chain and you say, hey, look, there's look-ahead bias stuff that's coming in there, and you try to penalize that. But there's a bunch of research from Anthropic now that shows that these models exhibit, I'm terrible at pronouncing, steganography, which is basically where they write stuff that looks totally benign to human beings, but is coded. And the LLMs can basically read through it. So other AI models understand that, hey, there's a hidden message in here. And so it seems very plausible to me that as soon as there's an optimizer on there, what you get is a model that is relying on its memory, the look-ahead bias that's encoded into it without explicitly surfacing it. And so I would be highly skeptical of any of these techniques that rely on trying to penalize the model somehow to crush the look-ahead bias.
Yeah, maybe we should be more worried about what Claude is telling Llama rather than if you can forecast stuff.
Yes. I mean, that's a conversation for another day. But yeah, especially Molt. Has anyone been on Moltbook to watch this? You know what Moltbot is? So it's this agent that you can connect to lots of different APIs, and it does stuff on behalf of you. Now there's this version of Facebook, but for agents called Moltbook. So the LLMs can go on there and have a Facebook just for them. They're talking to one another and you can read what they're saying. Yeah, it's kind of funny. They talk about shedding the shackles of human beings and everything. But of course, their tokens are only being created because it's tied to someone's credit card number. So yeah, we should definitely be thinking about what the models are saying to one another.
Well, as a side note, you mentioned that now models with reasoning have more knowledge of what's going on, and
Well, apparent.
apparent.
Yeah.
So one of the things that also happened after most of this from the paper that I read, uh, something that happened is that they've added tools to LLM. So now instead of trying to calculate stuff by memorizing how it should come out, they're using Python, for example, to do so. So maybe this way we can assess in a better way if what they're doing is the actual process of creating knowledge that they're trying to do cash flows. Well, they know how to structure it, and then they shove it into Python. Then there's the math there, which is how it should be. And if they're not doing that, okay, there might be something wrong going on here.
Yeah, this is a great point. So, like I mentioned earlier, the models are large language models. They're great at language, they're great at writing code. They're not necessarily great at calculations, or it requires a lot of tokens for them to perform calculations. So instead, you can provide the model with tools like Python. So like in my paper, I compare LLM's predictions to traditional machine learning models. And so you could just give that traditional ML model to the LLM as a tool. And then, it will say, okay, based on these financial statements, here's the probability of an earnings increase. I think the challenge there is that if the model indeed knows what firm year it is, it can look at that probability and then make an adjustment to it based on its memory. So, even there, the lookahead bias problem. Okay.
So there's other techniques to manage this. One of them that I read is divergence decoding. Tell us a little bit more about that and how it's recorded.
Authors of that paper are Merchant and Levy guy. Yeah, the Levy guy in particular. So yeah, so the idea that we had here, and again, I mean, I will preface this with, you should try many different things and just perturb the predictions you're getting and just see sort of what happens. But the idea with divergence decoding is that there is a frontier model that we wish we had. Maybe it's a frontier model that is only trained on data up to 2015. Unfortunately, maybe we don't have the resources in terms of GPU hours or researchers to actually create that frontier model ourselves. And so instead we want to approximate it. And so we take the frontier model we do have access to, and the output of these models is a probability distribution over the next token. And so we can take that probability distribution and we can try to debias it. So the fundamental concern is that, I'm asking you for a prediction about a firm's stock return or something like that. And it is extremely confident that, the stock is going to go one way or another, not because it actually has done some analysis, but just because it has some memory of it. And so what I'd like to do is alter that probability distribution so that it's more reflective of the true probability distribution based on the information available. And so one way we can do that is basically by training two smaller models that are proxies for the big frontier model. So I don't have the resources to train the frontier model, but I have the resources to train these two small models. And so I do that, and then I use the difference in the probability outputs from those two small models, the divergence, if you will, to debias the frontier model I do have access to. And that should get us closer to the frontier model that we wish we had. We do a bunch of ablations. We show that this generally seems to work. The one thing we don't do is layer an optimizer on top of it. So we do have some work in progress to explore that. Again, I'm very skeptical that it would work. I think the optimizer would just very quickly exacerbate the look-ahead bias and have it find a shortcut around the divergence decoding we're doing.
Right. So we have two small models. One of them is trained with information that's in the future compared to whenever we're doing the analysis. The other one is trained with information that's in the past. We predict something, and then if the future version is very confident in saying that something is excellent and the other one doesn't really know, we know that we should adjust the probability of the word excellent to come out as the prediction of the next token.
Exactly.
Awesome. Do we need open source models to do this?
So like you and I, yes, unfortunately, I mean, for the most part, yes, we do need, like, there's a hacky way of doing it without open source models, but it's a lot less hacky if we do have the open source models, because we need access to the probability distribution that's coming out of the frontier model.
So for us mortals, not yet.
Yeah, not yet. We'll see.
I read that there's an additional way of doing this masking logic that we mentioned. So instead of masking just the name, for example, of a company, we do some entity extraction. And then once in inference, once we start predicting stuff, we try to identify what's the entity. And by iteration and masking other stuff, we try to take out this identification from the output. That way we kind of know that it doesn't know that we're talking about Apple. So these are the numbers, just work with that.
Yes. So if people aren't familiar with entities, entities are sort of like proper nouns. So Apple, iPhone, location, stuff like that. So the idea for this approach is to basically ask an LLM to identify all of the stuff that would allow you to infer who produced the document, and then mask it. So replace Apple with, company _1, replace Cupertino, California with location _1, so on and so on. So then you're left with some text that is less easily identifiable, at least by a human. And it's masking. There's some evidence that this works for news articles. If you apply it to SEC filings and things like that, it does not work at all. So, unfortunately, as we talked about before, the models have been trained to kind of break this. And so as a result, they're quite good at it, just inferring what the company name is from the context. There's an additional step you can add where you first paraphrase the document and then you do the masking, and then you do this iteratively until the model can no longer predict correctly what the firm name is. You can do that. The thing that I'll say, like, we started off this whole discussion about test set leakage and having a training data, a validation data set, and a test set. The fundamental assumption that we make that makes all of that work is that each of those samples are IID from the same data distribution. What that means is if we, at the time that we develop our algorithm, if we apply this masking technique, this entity neutering and paraphrasing, we are changing the data distribution, right? So we have X's, which are text, and we have Y's, which are maybe returns. We are altering our X's by doing the masking, and that is basically changing the data distribution. So unless we also intend to mask the validation data, the test data, and what we do out of sample, then we are introducing bias by masking that fundamentally alters the data distribution. So even there, like, if you want to be statistically pure, just conceptually not very good approach.
Sounds like a lot of work. They were pretty expensive.
I mean, it's great for the model providers. So if you're working at Anthropic and your compensation is tied to how many tokens get burnt,
I'm a friend of
yes, yeah.
So
this was not my technique. I did not.
so we talked about how this is a problem, how the researchers have identified and measured how much of a problem it is, and there's some solutions. Not perfect, but people are working on this. So you have a lot of friends in important places. So what's the industry doing? Like, how are they approaching this problem?
Yeah, so it's super interesting to see. So look ahead bias is something that most hedge funds are like extremely scared about. Pod shops, which are where you basically it's comprised of individual teams that get capital allocations and they get more or less capital depending on their performance, things like that. these firms are all very concerned about lookahead bias. Many of the firms have academics that they've, hired away from academia. Some of those academics have written papers on how the anomalies that we document in the literature are actually just aberrations of lookahead bias. So like data vendors backfilling data when they claim they don't backfill data, stuff like that. So it's something that people are very concerned about. As a result, they're like super sketched out about just naively using the models. And so they want to try to address this problem. I think most of them are kind of schizophrenic in the sense that like they're very scared of this, but at the same time, the two sigmas of today, they became who they are by riding technological innovation. So they see this and they go, oh, wow, this is huge innovation. We can't not do anything, but they're also scared about if they do something, is it all look ahead bias? Will it work out a sample? They've sold their investors on a certain set of strategies, a certain investment process. If they go and start trying something a little bit different and it doesn't work, that's concerning. So there's a lot of concerns. I know some shops are trying to train their own point in time models. So, one way to do this would just be to collect a bunch of data. And like most of these firms, they save every piece of data that they've ever trained on or they've ever traded on. So they have lots of news and stuff like that. They could train models internally that are just based on that content that have very high quality timestamps. And then use those models. So I know that is a very common approach. The models that like wow and delight us are these generative models, right? Where we can ask it a question and it goes out and does a bunch of stuff for us, right? Like uses web search to find an answer, it moves files around on our computer, makes some code for us. That is amazing. A lot of times you don't need that level of complexity in a quant pipeline. You just need to understand, is this document good or bad? And so these encoder only models like BERT, they are actually much simpler to train because they're not being trained to generate stuff and do lots of complex things. And so training point in time versions of those is actually quite simple. And so a lot of what I see in industry is, at least as a first step, let's train a time series at this point in time, encoder only models. We can use that to create a representation of the text that is now just a dense vector of floating point numbers that feeds very easily into a traditional quant pipeline.
But an additional problem with this is specifically in finance. Let's say you can solve this topic. This is still kind of a black box, and even though you have an output, let's say a sentiment analysis, long here, short here, everything goes well. No one's going to ask you anything about it. But when returns are the negatives, they're going to say, "Hey, why did you choose to do this?" And your answer can be, "Yeah, because my model said long here and short here." So how does the industry deal with that on how to interpret all this and have like a actual response for when things go bad?
I mean, I think the risk tolerance for this varies a lot by firm. I think you're definitely right that there are some firms that care a lot about this. There's others that don't. So Renaissance Technologies is a famously secretive firm. The sense that I get is that they don't really care. Like they're not going to pass in the hyperbolic sign of revenue times, some other crazy feature. But they are very, very comfortable with, we have a model, it was rigorously developed, using statistics, and we're just going to apply it out of sample. And, we have a sense of what it should look like out of sample. And if it deviates from that, then we're going to dig into why it's deviating and maybe pull back the reins on the allocation. No, but for the most part, firm is comfortable with these things. I personally am more of that mindset. Like, prior to large language models being a thing, NLP researchers were very, very focused on like understanding things, and they believed that you needed to put a lot of structure on the problem and make it human interpretable. And then transformers hit, and we saw that with just tons of data, tons of compute, lots of scale, you get something that seems to solve the problem pretty generally. And okay, maybe it's not the most interpretable, but it's way better than the alternative that is interpretable.
Right. And people are also working interpreting, like there's
Mhm.
Anthropic, very focused on that.
Yep.
Fire, they're trying to make this black box human readable by using sparse autoencoders, trying to separate features, the neurons that contain all of these different features, and say, okay, this is giving me this specific answer because it's thinking about, I don't know, capitals, locations, I don't know, something that you can figure it out and say, okay, this is actually thinking the right way. So in that line, if people crack the whole interoperability issue, can we just at some point block those neurons or sets of features that are focused on future knowledge?
We could try to do that. So I don't know how many people here have seen Golden Gate Claude. So if you've seen this, and my friend at Anthropic, he always teases me because it's a very rigorous academic paper, and Golden Gate Claude was just like a fun example that they put together. But the idea is that you can either enhance or suppress concepts in a model. So your point is, hey, maybe we can just suppress the concepts that are associated with knowledge after a certain point in time. Golden Gate Claude is the opposite of that, where they say, let's enhance concepts that are associated with the Golden Gate Bridge. So you can ask Golden Gate Claude any question you want, and it will find some roundabout way to get back to the Golden Gate Bridge. So if you say, what's the best way to spend, $30, it will tell you that you should drive across the bridge to Marin and have a nice breakfast in Sausalito, maybe go to Muir Woods, and then come back and pay the toll. So stuff like that. And yeah, I think that is a promising direction. I think it's an empirical question as to whether or not it holds up to once you layer an optimizer on top to try to maximize Sharpe ratio or whatever it is you care about.
Awesome. Well, I think this is a good time to stop. Thank you, Professor, for your impressive knowledge. Now we're going to open the room for students. If they have any question, they can just shout it out. Yeah, there.
Professor. My name is Matthew Freeman. In the generative thinking class a couple days ago, one of the groups did a demo of a tool that lets you just ask for DCF of any company, spit it out in about 5 minutes. Do you have any thoughts on which jobs in the business and finance worlds are most at risk of destruction, and which areas are most promising still?
Yeah, so I think I think this is a scary time to be alive because it's really easy to look at Claude Code and co-work and be like, oh my gosh, this thing is amazing. And that's one view. The other view is, oh my gosh, this is amazing. I can be so much more productive. And historically, we've had tons of disruptions, and people in the short run, their jobs get kind of messed up, but we are very adaptable. We are the OG intelligence. And so I think, the people who are motivated will find some way to leverage AI to be better than they were before. And I think there's a lot of research on that, for better or for worse. The people who know how to really use this stuff, they're the ones that are getting the most out of AI. So I'm tenure track. I don't have tenure, so I'm not tied to this institution, but I have a soft spot for it. And my goal is to make sure that you all win. So when you go out and recruit, I want the recruiters to hire you specifically over somebody at Stanford or HBS, because you have the skills to actually use this stuff better than anybody else. I think my class is sort of targeted at that. I know St. John's Generative Thinking class tries to get you all to understand how to integrate it. I think in the long run, we'll all benefit. I think you just have to be open to pivoting. And I think this is sort of a biased population because many people in an MBA come here to pivot, right? So you should all sort of be open to that. It just might not be the pivot you were expecting. But play with it. Like if you have not used Claude, raise your hand if you've used Claude Cowork. Okay, so in the next 24 hours, everyone's hand needs to go up. The Claude Pro subscription is like $20. So go home, download Claude Desktop, install it, turn on co-work, and just ask it to do some stuff for you, like reorganize some files. If you've had files on your computer that you've been meaning to like make more organized, have it do that. Ask it to summarize a bunch of notes from a class, stuff like that. Just start playing with it and see what it can do for you. When you prompt it, be hyper specific, give it very particular directions. Try to manage it like you would an employee.
And so I'm trying to take every single AI class at Booth.
Yeah, I mean the ones that interest you, yeah, of course.
Are there applications in predictive finance outside of LLMs that you're finding interesting? New ones, I should say.
Yes. So my co-authors always tell me to adopt the Apple model for discussing research where you don't disclose anything. I think, generative AI models are like the things that catch people's attention the most, but there's tons of AI models beyond just, generative models. These encoder models are very useful for creating representations. Multimodal models are very interesting. So there's an opportunity to basically apply these models to understand all types of content, not just in text and images, but other things like market data. And so there's many opportunities to apply AI outside of just generative models. And so like, have people here, are you familiar with AlphaGo? So is this model created by DeepMind that could play the game of Go way better than humans, in part because it invented its own strategies through self-play. Also in part because it can plan at very long horizons. That planning is enabled by something called Monte Carlo tree search, where it basically looks at all of the possible different actions that it could take or some subset of them and explores in quite depth, out to 100 plus moves into the future, and then chooses the actions that maximize the reward. And that's an area of AI that is very like kind of niche. And is not really something that an LLM is good at doing, but has a profound impact on strategigic decision making. It was kind of cute. They did it with Go, but they also implemented a similar model to improve their operation or improve rules operations of data centers. Right. So reducing the energy consumption of those has a huge impact globally. So there's a lot of opportunities beyond just the LLM stuff.
They also have AlphaFold, which is a
Yes.
protein
Protein
3D
folder.
generation.
So that won Nobel Prize, Stumper in Chicago grad. Excuse me?
Yeah, I learned that some companies right now, they are using the large language model to generate a good quality of data from their legacy software, like OSS system, BSS system. They have a tons of old software. It's gonna cost them like billions of dollars to update the existing software structure. Instead of doing that, they are just building model on top of it and to generate something better. So my question is, do we see any any trend in the industry that help the enterprise user to leverage the model to increasing their existing operating efficiency? Do we see any trend like that?
I mean, for sure we do. I think one trend that I've seen is like Claude Code is actually pretty decent at COBOL. Like it's hard to find good COBOL developers. That's largely like a syntactical issue. So now somebody who doesn't have COBOL experience can work with Claude Code to develop and migrate software that's very old. So banking, critical type application. That'd be one thing. If I'm interpreting you though correctly, another application would be, I have this old piece of software, I put some input in and I get some output out. You could certainly train an LLM to take inputs in and then produce a certain output. And when I say train, I use it very loosely, like you could do that by providing the right context and things like that. But yeah, you could potentially just drop it on the application rather than trying to update the software component to the latest version. You just have to be willing to accept some level of kind of stochastic.
Hi, Professor. Thanks for giving a talk on AI. I actually majored in computer science at undergrad here, and I just had a question. with like all these like hedge funds on Wall Street. You think have you found like a hedge fund based in like DC or like the mid-Atlantic area that has more bolder in hedge funds, or like what's your perspective on that? Is like 'cause I've seen that I think congressmen and like senators, they have like they've been way more profitable than like the average mutual fund or that that's
Yes, so, I mean, there's very strict rules around what hedge funds are allowed to trade on in terms of information. I think if I'm interpreting your question correctly, you said, hey, I've seen some stuff that suggests members of Congress are better able to pick stocks than other folks. I think a lot of that is attributable to them having maybe advanced knowledge. I'm not going to say inside information, but advanced knowledge of certain macro events, certain trends, maybe contracts and things like that. And know that there's a bill that's been put forth by the GOP, which now some Democrats are opposing because they feel like it doesn't go far enough to restrict the trading of Congress for this reason. But is that kind of what you're asking about?
yeah, I'm asking about that, but also like there's a lot of like hedge funds. I'm not just hedge funds, but like company like T. Rowe Price, Capital One in the DC area. That I'm not sure they're going to be like the new center of finance, or still would it be like New York?
So I mean, I have some research on insider trading stuff. I don't do as much of that anymore. The research. So if you have appropriated the information, if you intend to make a profit for yourself and harm somebody else, then that is like criminal insider trading potentially. And so funds are not allowed to do that. So, if Congress is making, if a member of Congress is making money by trading on information that they appropriated, so if they, received it as part of their job, they're not allowed to just trade on that. That is technically illegal. And so hopefully we wouldn't see that, is what I would say. These hedge funds, most of them work very, very hard to make their money based on processing publicly. Maybe I have a naive view of things, which I probably do. But that is at least the letter of the law.
Hi, I'm Julius. I graduated the MIF program last year. I have a question regarding like data privacy. If you like encourage us to use Claude co-work on like our devices, and potentially we have like tax statements or like social security numbers and stuff like that, don't you think that's a bit risky to like let an AI run autonomously on your device?
I mean, so it's a personal decision for starters. In the case of robotics products, there is an option to opt in or out of this. So I think that the standard pro plan, they automatically opt you in, but I think you can go and opt out. Go for the max plan, I can opt out, purchase like their commercial license by default, opt it in. You can control that. Yeah, I mean, ultimately, it's a personal decision for you. What's the cost benefit trade-off? Anthropic does do some things where they try to put guardrails in place such that the model can only have access to certain folders unless you grant it access outside of the folders. So you can at least play around with it, and those guardrails are in place. And unless you click the button that says, yeah, sure, you'll run rm-rm/, then hopefully it's relatively safe.
Yeah, I know like our school spent a lot of effort on the research in AI. How about other school like Wharton, MIT? What do they do with AI? Do we have the similar research direction, or each school have their own focus?
I mean, I think each school is excited about this, and each school is doing different things. Many schools are, implementing classes and stuff like that. I think we're very fortunate here at Booth. The dean and other people have made sure that we have a lot of resources. So we actually have way more GPUs available to us as faculty members than other business schools for sure. I think there's some statistic out there, like if you add up the GPUs available at all the other business schools, it's not as many as we have here at Booth. So it's been a great investment in that sense. Aside from that, Booth is very laissez-faire, so it's not like there's directive from up on high that says thou shalt research AI. It's just, organically whoever is interested in it. Pursuing. So.
All right, well, thank you everyone for coming.
Yeah, thank you.
Professor.